It's a vasodilator, but more than that, it's a signaling molecule. And this study from 2015 revealed to us that you need nitric oxide bound to hemoglobin to release oxygen during the arterial venous transit. So when we breathe in to our lungs, the red blood cells pick up oxygen. When it goes from the arterial side to the venous side through the capillaries, it goes through an allosteric transition, and this releases oxygen. However, if nitric oxide is not bound to hemoglobin, oxygen does not come off. But more than that, nitric oxide is involved in every biological function, from maintaining the integrity of the cardiovascular system, controls gut motility. It's the molecule that tells our own stem cells to mobilize and differentiate. It's a neurotransmitter in the central nervous system, controls cell cycle. It's a bronchodilator, so important in the respiratory tract, controls blood flow to the sex organs. In fact, the first sign and symptom of nitric oxide deficiency is erectile dysfunction. And then really importantly, in immunology, our macrophages and neutrophils make nitric oxide to kill off viruses and bacteria or any invading pathogen. So if your body can't elicit a robust immune response and generate nitric oxide, you become immunocompromised and you become susceptible to viral and bacterial infections. So in terms of nitric oxide, there's two ways the body makes nitric oxide. One is through an enzyme called nitric oxide synthase. That enzyme converts arginine to nitric oxide. And then the other is through nitrate that is found primarily in green leafy vegetables. And then the bacteria in the body convert that to nitrite and nitric oxide. So one pathway can compensate for the other, but when you lose both, you become nitric oxide deficient and you start to develop the symptoms that we reviewed earlier. But this pathway is what becomes dysfunctional the older we get, and this is what's called endothelial dysfunction. The older you get, the less nitric oxide you make through the nitric oxide synthase enzyme. So by the time you're 40 years old, you only have about 50% of the nitric oxide producing capacity you had when you were younger. Outside of nitric oxide, what I've learned in academia is that all diseases are caused by two things and two things only. Number one, the body's exposed to something that it doesn't need, or it's missing something that it does need. So if you remove the toxins and if you replete missing nutrients, the body heals itself. But the end result of both of those is that there's a disruption in nitric oxide production. You have decreased circulation, increased inflammation, oxidative stress, and immune dysfunction. And that is hallmark of every single human chronic disease known to man. If we go back to the basics, that a man is as old as his arteries, we can begin to look at what happens in the cardiovascular system. So the older we get, you start to get this plaque deposition. This plaque becomes unstable, it ruptures, and that's a heart attack or stroke. However, we begin to try to figure out what is nitric oxide, where does nitric oxide play in this whole sequence of events. And what's revealed is that if your body can make nitric oxide in what we call endothelial function, if you have good endothelial function and sufficient nitric oxide, you prevent the onset and progression of cardiovascular disease. So when you lose the ability to make nitric oxide, that sets the stage for inflammation, oxidative stress, and immune dysfunction. We've known for many, many years that once you get diabetes, it leads to decrease in nitric oxide production, and that increases the cardiovascular disease severity. And people typically don't die of diabetes, they die of heart attack or stroke or amputations or infections from diabetes. And all that is related to a lack of nitric oxide production. Furthermore, your ability to exercise is predicted by how well your body makes nitric oxide. So if your blood vessels can make a lot of nitric oxide, then you become a well-trained athlete and you can perform very well. But to the contrary, if your body can't make nitric oxide, you fail to increase plasma nitrites in response to exercise, and you fail on exercise stress test. So the most important thing that I hope to teach you today is that nitric oxide deficiency causes chronic disease, including cardiovascular disease, and it increases your sickness and mortality from viral infection. So the most important thing you can do is enhance and restore your body's ability to make single molecule nitric oxide. So if every single chronic disease is characterized by decreased blood flow to the organ, and it's known scientifically and clinically that you can restore blood flow, then you can correct most, if not all, chronic diseases. So the fundamental question every person should be asking themselves is, how do you restore blood flow and perfusion to all cells, tissues, and organs of the body? And then the human nitrogen cycle is a denitrification pathway. So for instance, if we eat some spinach, kale, or beets, for example, then 90 minutes after we consume this meal, it's concentrated in our salivary gland. So it's taken up in the proximal gut, delivered through our circulatory system, and secreted through our saliva. And then when the saliva is secreted, there are bacteria that live on the crypts of the tongue that reduce nitrate to nitrite and nitric oxide. And then when we swallow our own saliva, the pKa of nitrite is 3.4. So provided there's stomach acid being produced, the nitrite turns into nitric oxide, and that fuels nitric oxide production throughout the body. However, if we're using antacids, we disrupt this pathway. If we're using mouthwash, we disrupt this pathway. So then the question was, how much nitrate do we need to see an effect on blood pressure, or to see an effect on exercise performance? And you'll see that if you review the literature, you need about 300 to 400 milligrams. We've surveyed the standard American diet, or what we call the SAD diet. And Americans are only getting about 150 milligrams of nitrate per day. So just like most Americans are deficient in selenium and magnesium and iodine, we're deficient in nitrate. So if you're deficient in vitamin D, what do? You supplement vitamin D. If you're deficient in magnesium, you supplement magnesium. If you're deficient in nitrate, which every single American is, you supplement with nitrate. That's how you fix these problems. Next, we went and just tried to determine if we could change dietary guidelines, how much broccoli or celery or spinach would one need to eat to get 300 or 400 milligrams of nitrate to normalize your blood pressure. So we went to 5 cities across the U.S., Chicago, Dallas, Los Angeles, New York, and Raleigh, bought different classes of vegetables, and then quantified the nitrate in here. And this is a busy slide and lots of numbers on it. But let's just take, for example, celery. If you bought celery in Dallas or Los Angeles, you could eat 6 or 7 stalks of celery and get enough to get the 300 to 400 milligrams of nitrate you would need that would normalize your blood pressure. However, if you lived in New York, you'd have to eat 30 or 40 stalks of celery to get enough nitrate to lower your blood pressure. So there are regional differences in this. There's differences between vegetable categories. And perhaps most interestingly, these are conventionally grown vegetables. We compared that to organically grown vegetables and find that organically grown vegetables have on average about 10 times less nitrate than conventionally grown. So the point is, you cannot eat enough organically grown vegetables to get enough nitrate to normalize your blood pressure. And the reason for that is to get an organic label, there's restrictions on nitrogen-based fertilizers added to the soil. So the soils become deficient in nitrogen, the vegetables become deficient in nitrate, as well as many other essential nutrients. So then what does this mean in real life to patients? Well, you have to do 2 things. Stop doing the things that disrupt nitric oxide production and start doing the things that promote and restore it. So if you're using mouthwash, you have to stop. If you're using fluoride toothpaste, you have to stop. Fluoride's a neurotoxin, it's an antiseptic, and it kills your thyroid function. So stop using mouthwash, stop using fluoride, let these good bacteria repopulate, flourish, and do their job. If you're using antacids, you have to stop using antacids. This shuts down nitric oxide production. Clinical data show that people who have been on antacids for 3 to 5 years have a 30 to 40% higher incidence of heart attack and stroke because you're disrupting nitric oxide production. And then stop eating high carbohydrate, highly processed junk food. The high glucose causes glycation of the enzyme and shuts down nitric oxide production. So once you do that, it's going to make some transformative effects. And then you can go a step further and just change your diet, throw in some more green leafy vegetables, start exercising, sit in an infrared sauna. The light therapy promotes nitric oxide production. If you don't want to do all that, then you absolutely must take a safe and effective nitric oxide supplement. We understand this pathway now, the nitrate, nitrite, nitric oxide pathway. You titrate up your nitrate through supplementation that feeds the nitrate reducing bacteria. So nitrate actually acts as a prebiotic as long as you're not using mouthwash or fluoride. that potentiates this reduction of nitrate to nitrite, nitric oxide. And as I've shown you here in both preclinical and clinical models, this does the trick. But this is really important here. So this isn't like a switch that you turn on or off or turn off. Loss of nitric oxide is like a battery. You lose this charge, and eventually one day there's going to be no charge at all. So you have to completely recharge this battery, continually recharge it. And so how do you do this? Well, simplest thing and most cost-effective thing is supplement with a standardized nitrate product. I've shown you that American population, perhaps the world population, is deficient in nitrate, so you have to supplement.